Hello everyone. We all tech enthusiasts and professionals have one common problem, which is we find ourselves tangled in many cables, juggling between adapters and hubs in order to connect to our day-to-day devices, SD cards, USB sticks, microcontrollers, and our industrial machines for communicating with them or for high-speed data transfer or to power them. And also sometimes we find in a situation where our PC got maxed out ports. And we know all this is very frustrating. So to solve this problem, today we introduce the all-in-one USB hub. This USB hub extends one USB 3.1 Type-C to two USB 3.1 Type-C, two USB 3.1 Type-A, a SD card, a micro SD card, a UART/TTL port, a RS485 port, a RS232 port with 3.3 and 5 volt logic. So this is what you require in your pockets in order to communicate to your industrial machines, to work on your microcontroller projects for programming and debugging, and for high-speed data transfers. Before we jump into building the all-in-one USB hub, let us thank today's video sponsor DigiKey. This video is sponsored by DigiKey, who is also the supplier of components used in this project. DigiKey provides more than 15.9 million components from over 3,000 quality name brand manufacturers with products in stock available for immediate shipment. DigiKey can also act as your one-stop shop for all your electronic component needs. Also, with their fast shipment and excellent customer service, you can trust that the components will arrive on time and in top condition. So do remember to check out DigiKey for your next project. First, let's jump into the schematic of this project. At the core of the project, we have USB5926CT, which is a USB hub IC from Microchip. It is designed to expand one USB port to 6 USB ports and provides advanced features as high-speed data transfer up to 5 Gbps, power management, and support UART, I2C, and SPI interfaces. Next, we have the upstream port schematic featuring UPD350A, which is a power delivery IC from Microchip designed for USB PD communication and ensures efficient interaction between USB host and the peripheral devices. It is paired with a Type-C male connector serving as the interface between our hub and the PC. For the downstream USB Type-C, we are using the same UPD530A IC paired with Type-C female connectors. This schematic is duplicated for the second downstream Type-C port as well. Moving to the USB Type-A downstream ports, we have these two identical schematics, each having MIC2009 IC, which is a high-speed USB power distribution switch. This powers downstream devices as well as offers overcurrent and thermal protection. The design also includes the popular CP2102N IC from Silicon Labs, which is a USB to UART bridge, enabling the TTL communication to our hub. For the voltage selection between 3.3 and 5 volt for UART, RS485 and for RS232, we are using the same MIC2009 power distribution switch IC connected to a RFM0505, which is a 5 volt DC to 5 volt DC converter providing electrical isolation between input and the output circuit. The 5 volt output is then fed to ADM7171 IC, which is a 3.3 volt linear regulator from analog devices. A two-state switch is connected to this circuit for manual selection of voltage between 3.3 volt and 5 volt. Additionally, we have a three-state switch for selecting the UART or RS485 or the RS232 modes. For the RS485, we are using SP485REN IC, and for the RS232, we are using SP3232EEY IC, which are the transceiver ICs for the respective. Finally, the hub features the GL3224 IC, which is a USB SD card reader controller connected with a SD and a micro SD card slots. This is the overall schematic of our hub. We plotted this schematic on a 4-layer PCB and assembled it by soldering all the components on the PCB. And here is the result. Now let's put our USB hub to the test by connecting it to a PC. As soon as we connect the hub to the PC, the system detects the CP2102. You can confirm the same from Arduino IDE's port selection menu. For testing the USB port, first I have connected a Arduino Uno to one of the type A port and it got detected. Then I connected a ESP32 board to the second type A port and it got detected as well. Next I connected another ESP32 board to a type C port and as expected it got detected. For SD card test, I have inserted a SD card and then followed by a micro SD card and they both got detected as well. Now for testing the UART communication, I took a 4-pin JST connector and shorted the TX and RX pin and connected the JST connector to the UART port. You can connect any microcontroller instead for testing, but remember to set the voltage according to the microcontroller's requirement. Now open the Arduino IDE and send a message in serial port. The message gets looped back confirming the working of UART communication. Now to test the RS232, we took the same JST connector, sorted the RX and TX pins and repeated the same Arduino serial process to send a message. And same as previous, the message is looped back confirming the functioning of RS232. For closing the PCB, we have designed a enclosure and 3D printed it. It is assembled using 5 M3 screws. This USB hub is not only versatile, compact and portable, but also it supports all your Windows, Mac and Linux systems. So that's it for now. Remember to check out DigiKey for your next innovation.
DigiKey.